Okay. So before jumping into the other things, let's try to understand a little history of the things. And so basically, in 1950, there was a person called Turing. He came up with something called Turing test. So what he said is, he simply asked one question: can machines think? Can machines think? What does it mean? He meant that, if I say in simple terms, can machine fool a human into thinking it's a human? If I try to make it more simple for you people, let's say a question was asked up, a written question was asked up, and the question was given to a machine and a human. When the answer was given from the machine and the human back to you, you are not able to distinguish which answer is given by machine and which answer is given by human. That is what his question was. Can machines think, or can machines fool human into thinking it's a human? So he just came with a question. He just came with a test, what he called the Turing test. He have no theory behind it. He have no logic behind it. But why this matter is because in 1950s, this guy made other things in a different way. Rather than writing logics in if and else, can we think of generating some code, some logics, which can make machines think, and what we can see today in the world of GenAI. Okay, so in 1950s, he just came with the concept, but that concept really changed the thinking behind the scenes. It set up the ideology groundwork behind the thinking machines, like the GenAI today. So a human talks to both machine and other human, the output came up, and you can't reliably tell which came from the human and which came from the machine. That is what the question was, but this changed the whole thinking process, whole psychology, whole ideological groundwork. And then in 1957, there was a person called perceptron. So basically, there was a person called Frank who came up with a concept called perceptron. So perceptron was introduced by Frank Rosenblatt in 1957. Was the first neural network model that could learn from data. In simple terms, it mimics how a human neuron works by taking multiple inputs, applying some weights, summing them, passing the results to an activation function to produce an output, usually 0 or 1. Let me try to simplify it for you. So let's say I want to hire someone. Let's say I just want to hire someone. So what I'll do is I'll ask him some simple questions which might be answered in yes or no. Okay, so I'll ask him, do you have experience? He says yes or no. Do you have a degree? He would say yes or no. Are you available full time? He will say yes or no. Now, based on these answers given by this person, I will give some weight to each and every question. So let's say I give degree a weight of 2, I give experience a weight of 5, I give full time a weight of 2. Then based on the question answered yes or no, yes is 1, no is 0, I sum up all these weights. And finally, I would be coming up with some number. The number might be 5, 10, 20, I don't know. Now, based on this number, I will take a call whether I should hire him or not. So technically, I asked him some questions which were answered in yes or no. Each question has a weight. I summed up the weight, and finally, I came up with some final number. And that final number made me decide hire or not hire. So same way this model also worked. So what this model does is basically takes few inputs. Basically it adds them. So basically what happens is perceptron layers basically predicted something, and each layer basically the decision made by each layer was added up in weighted sum, and finally the model output was able to predict up to something. Although it has a lot of problems, a lot of things, but basically why it mattered is because it was the first algorithm that could learn from a labeled data. What does the labeled data means? Anyone want to answer? What is the labeled data? So basically labeled data is basically basically, let's say I want to categorize an image as a cat image or not. So what we do is we feed more a lot of images. Image might be cat sleeping, cat onto the ocean, cat onto a sand, cat onto a table, and each of the image would have a tag. Tag might be cat sleeping, or it's a cat image or not image. And I'll also feed up a lot of other images. Might be a dog image, might be a cow image. So when I have given the input as well as what is that input, the model can learn from it. So I've tagged the data. That's called labeled data. And why this model really mattered up is because it was able to learn from the labeled data itself. Then basically came up with a backpropagation algorithm in 1960s. Why it became possible? Because it's a key for algorithm that made deep learning possible. So basically, it also worked like perceptron model, but it was basically able to rectify its mistake. How? As the name itself says, backpropagation. Backpropagation basically sends the error backward through the layers. So basically, as I explained up in the perceptron layer, I have multiple layers. Each layer might be answering something, question and answer. And each answer I give some weight. And based on those weights is able to figure me an answer. So let's say I have a model which is trying to predict and it's an image of cat or not. So when a model is trying to predict it's an image of cat or not, this model is basically doing it with multiple layers, and each layer have its own weight. So now when let's say model predicted whether the image is of cat or not, and finally from the labeled data is figured out, oh no, I predicted wrongly, it will go back in each and every layer and see and which layer's weight I can change up. Basically, each layer have its own weight. So it will go back and will try to fine tune the weights. So that's what is called backpropagation. So basically, based on the mistake what is done out, it can go back into the different layers, and each layer would be fine-tuned. And that's the reason this backpropagation really matters us today, because this laid the concept of what is done today into deep learning. So how it works? Input passes through a network, forward pass, error, difference between the output and the target. What should be the target? What is the output? Backpropagate sends that error backwards through the layers. Weights are updated to reduce the error using the gradient descent. Right? And also it solved a lot of other things like XOR and other problems which were there in the perceptron model, but I'm not going deeper into that part right now.